Hi guys, so in this class we'll be talking about measurements and units and as well as dimensions. And before I actually talk about measurements, I always like to talk about physical quantities because what are we measuring? Measurements of what? So it's very important for us to actually know what physical quantities are. Now physical quantities are basically terms that you use to represent um, parameters that you can sense, that you can feel, that are more like have like a physical presence. Like temperature now, you can have a feel, you can sense the temperature changing, especially when temperature is either increasing sharply or decreasing sharply. The same thing for your length, you can have a sense of, oh, this thing is wide, this thing is narrow. So you get, and then you can talk about the time as well. So time is in the sense that, oh, the time is fast, the time is too fast. At so time I was doing this, at so time I was doing this. So those are physical quantities. And due to our curiosity, we decided to just think, society just thought, oh, this thing that we can feel, how can we quantify them? And the way you can quantify them is by what? By actually what? Measuring them. Which is why we have what? Measurement. And the only way you can measure them is by using what? Measuring instrument. So which leads us to measurements and units. And for every quantities that you have a unit, in the sense that not every single time that you are going to be writing, oh, you have this parameter, let's say length, you now say length is equal to 29. It does not make complete sense. This is where your unit now comes in. Unit gives you an idea of, okay, this particular value, this particular quantity belongs to this physical quantities, without actually stating that. And it makes more sense to actually put it that way. Like it makes more sense to say something like 29 centimeter rather than length 29. It doesn't really make sense per se. And it gives you a way of actually either expanding that value or reducing it so that you can actually like note it down. For example, now let's say you have let's say if you had to say 1,000, or if you had to say 1 million, if I were to write down 1 million meters, it will be longer compared to if you had to say when I say 1 kilometer, because 1 kilometer is the same thing as 1,000 meters. Do you get? So that's where using units actually comes in. So units are basically just what you actually use to indicate that this particular parameters, this particular quantity belongs to this particular physical quantities. And for length now, the unit of length is meter. That's the standard. Now we have SI unit, and then we have some other, you have CGS unit as well too. But then the one you are concerned about with in physics is SI unit. Now the SI unit for length is meter, the SI unit of time is seconds, the SI unit of mass is kilogram, the SI unit of temperature is Kelvin, not Celsius or Fahrenheit. Take note. And then you have quite a lot of them as well too. I don't want to like jump too much into that because we're still going to talk about it. So let's not jump into measurements or measurement of length. Now, I already made mention of the fact that for length, you have the unit to be what? To be meter. Now, you can have different units that you can use for them. A particular unit that you can use for length is also miles. You can use inches. You can use kilometer. You can use quite a lot of them. So, but then the one that is accepted in physics is meter. Now, we have different instruments for measuring length. But then the one that we use in physics, we have your meter rule, you have your vernier caliper, and then you have your micrometer screw gauge. Now, for your meter rule, we all have seen meter rule, and you observe there are some things that you should take note when you are measuring instrument. The first is the smallest division on that measuring instrument, and then the second is the leading accuracy of that measuring instrument. So for meter rule now, let's start with meter rule. The meter rule is used to measure what? Length of an object, breadth of an object, width of an object, height, and so on. Basically, lengths that are much in magnitude. And the smallest division on the meter rule, if you pick up a meter rule now, the smallest division on the meter rule will be 1 millimeter. So that means if you check the difference between one division and the other division is what, 1 millimeter. Now, with most times when you are trying to measure using a meter rule, sometimes the parameter you're trying to measure will fall in between the two divisions, and in that case you always tend to like approximate and say, okay, this is like 0.5. Do you get? It's like 0.5. So which is why the reading accuracy of a meter rule is what, 0.5, whereas the smallest division of a meter rule is what, is 1 millimeter. Do you get? So that's worthy of noting that for your meter rule, the smallest division is 1 millimeter, while the reading accuracy now is what, 0.5 millimeter. And take note that your meter rule is to measure what, large length are larger in mass, like breadth of a book, length of a book, etc, etc. Now moving on, let's talk about that of vernier caliper. Now your vernier caliper is used to measure internal and external diameter of cylindrical objects basically. You also used to measure the thickness of that cylindrical object as well. But then the thickness of that cylindrical object is the same as what is the external diameter. So that's still the same. We're still saying the same thing. And the vernier caliper is a little bit different due to the fact that it has two scales. You have the main scale and then you have the vernier scale. Now the main scale is calibrated in centimeters, although some of them are calibrated in millimeters, but then it's basically calibrated in centimeters. And then you now have your vernier scale on the other hand. Now anytime you're trying to measure, or you are trying to read the vernier caliper, or you're trying to use the vernier caliper to measure a particular parameter, you are meant to add the main scale, the value that you get on your main scale, to that you have on your vernier scale. And the way you do it is you start your reading on the main scale. So you have like two sides, main scale, vernier scale. So you start from the main scale. So whatever value you have, you count it, and then where you will stop will be where the vernier scale starts. What I mean by that is, you notice that the main scale is like right in front, and then after the main scale, that's when you now have your vernier scale. So if you are trying to measure, you are going to stop your reading of your main scale where the vernier scale starts. So that is where you end your main scale. So you write that down, and then you now jump to your vernier scale, and then you are going to start counting. Now where you are going to stop, I forget to mention that your vernier scale has 9 divisions, and for your entire vernier scale is equal to 1 millimeter. So that means that each division on a vernier scale will give you 0.1 millimeter, which means that the smallest division on your vernier caliper is what, 0.1 millimeter, which is also the same thing as its reading accuracy. So the reading accuracy and the smallest division on the vernier caliper is what, 0.1 millimeter. So that means each division on that vernier scale will give us 0.1 millimeter. Now we are not going to start counting. Now when you start counting 1, 2, 3, 4, 5, now we are going to stop where the line on the vernier scale coincide with the line on the main scale. So that's where you are going to stop your reading of your vernier scale from. Then after taking note of that, so let's say you counted like 6, so that will be 6 times, each division is what, 0.1 millimeter, so that will be 6 times 0.1 millimeter. So you are going to get to 0.6 millimeter. Then you can now add your vernier scale and your main scale together to get your reading. So that's how you make use of your vernier caliper. Now moving on, let's talk about your micrometer screw gauge. Now your micrometer screw gauge and your vernier caliper are very different because both of them have two scales. You have the main scale on the micrometer scale, and you have the vernier scale also on the micrometer scale, but then they always tend to call it thimble scale, THIMBLE. Then you add your scale. Now the difference now comes in the fact that the way the thimble scale or the vernier scale of the micrometer scale is calibrated is quite different. So now you have your you have your vernier scale, 1 2 3. You have your I said your vernier scale, you have your main scale horizontally, and then you now have your vernier scale, your thimble scale calibrated on a cylindrical thimble. So that means instead of just making it horizontally like that of your main scale, it's calibrated around something circular. It's not a cylindrical thimble. Now, and for your reading is also similar. You start your reading of your verniers or your main scale. You count. Now you are going to stop where the that cylindrical thimble starts. So that's why you are counting 1 2 3 4 5, and then the next stop you have after that 4, like 1 2 3 4. The next thing you have after that 4 is the thimble. So that you are going to stop your reading of your main scale on that 4. So you have 4, and then you now jump to your thimble scale or your vernier scale. Now your thimble scale, the entire length of your thimble scale is 0.5 millimeter. Now that 0.5 millimeter, that entire thimble scale is now made up of 50 divisions. Now if you now divide that 0.5 millimeter by that 50 divisions, so you're going to get 0.01 millimeter. So that means each division on the thimble scale is equal to 0.01 millimeter. So let's say after that jumping to your thimble scale, you now decide to after jumping to your thimble scale, you notice that the horizontal line of the main scale coincides with like 21 division on the thimble scale. So that means your vernier scale or your thimble scale will be 21 times each division is 0.01. So that's 21 times 0.01. That will give 0.21, and then you can now add it to your 4. So you are going to get 4.21 millimeter as your reading for that micrometer screw gauge. Now the same way for vernier scale, the reading accuracy and the smallest division of a micrometer screw gauge are both the same thing. And I told you that each division on the thimble scale of a micrometer screw gauge is 0.01. That's the smallest division that you can read using the instrument. So that's also the reading accuracy. That's also the smallest division. You have 0.01 millimeter as your reading accuracy and as well your smallest division on the micrometer screw gauge. And take note that your micrometer screw gauge is used to measure thickness of the wire, something that is smaller. So that's why I always say that it's very important for you to actually know the trend from your micrometer screw gauge, from your meter rule to your vernier caliper to your micrometer screw gauge. So that means your meter rule is measuring larger mass, your vernier caliper is measuring a mass, length. Your meter rule is measuring a large mass, a large length. Then your vernier caliper is measuring a lesser length, while your micrometer screw gauge is measuring the least length. I hope you get that. So that's that for measurement of your length. Now let's not talk about areas. I shouldn't really talk about it because measuring area is not really like something that you actually measure. You just make use of the of your length, your radius, and just like basically your length to actually get your area and your volume. Now for your area, you just use mathematical formulas. Like for a square object, now you are going to use length times length. For a rectangular object, you are going to use length times breadth. For a circular object, you are going to use pi half square. For what else? What else? So those are the ones that I can recall. Okay, yeah. For a triangle, now you are going to use half base times height. So basically, you're just use formulas. So it's very important that you actually know most formulas for calculating area of a solid or of a surface, basically. Now for concerning the volume, you can determine the volume of your object if depending on whether the object whether the solid is actually irregular or regular. Now if it's irregular, then you are going to use your measuring cylinder, or either use your measuring cylinder alone or use your measuring cylinder and an Iruka can. Now Iruka can is that can that has like a tube, so that when you pour fluid into that particular Iruka can, it gets to a point, to that level where the tube is starting from, that the water will start pouring away. So that's your Iruka can. And the way you use this is for measuring, like for measuring cylinder, you're trying to measure irregular solids, because you can't really measure the length, you can't measure anything. So what you do is you attach a string to that irregular solid, you pour liquid into the measuring cylinder, and then you dip your irregular solid into that measuring cylinder. And as you dip into the measuring cylinder, you notice that the level of the liquid will rise in the measuring cylinder. So the difference between the initial and the final volume will be the volume of your irregular solid. While for Iruka can, you fill the Iruka can to the brim, to the point where the liquid starts like pour away from that tube, and then you tie a string to your irregular solid, and then you dip it into your Iruka can. The water, certain volume of liquid will be displaced, and then you just make sure that they are displaced in the measuring cylinder, and then you can now measure from the measuring cylinder you can now determine the volume of the irregular solid, because the volume of the liquid displaced is also the same thing as the volume of the irregular solid. So that's how you use that's how you measure the volume of your irregular solid. But then for all of those, all others like cuboid, cube and the rest, you just use your formula. For cube you use length times length times length. For cuboid you use length times breadth times height, and so on and so forth. So with that said, now we've talked about the volume, we've talked about areas. Now let's now talk about the time, measurement of time. Now time is a quantity that distributes between two events. So that means, okay, now I'm standing at this point at this particular time, I'm changing my position later on. So the difference between those two times, those 2 points, is those two events is actually what's your time. And what they use to measure time, that is actually used in to measure time in physics, is stopwatch. And the unit of the time, I think it's very important I mentioned that, is what is seconds. Even though we have other units for measuring time, like minutes, hours, weeks, days, and the rest, but then the one that is acceptable is what is seconds. Okay. Now then there were a lot of measuring instruments that were used in the olden days to measure time. For example, you have your sound clock, which I've seen this in movies. You have your sound clock, you have your like your normal solar day, where they determine the shadow of a person to determine what the time is, the sunset, the sunrise, and so on and so forth. And it's very important for me to note it that the most accurate clock that you can ever use to actually measure time is simple atomic clock or quartz crystal clock. Those are the two most accurate clock in the world right now. And as I told you before, that the instrument that we use to measure time in the lab is your stopwatch. So that means it definitely has a leading accuracy. Now the leading accuracy of your stopwatch is 0.01 seconds. 0.01 seconds. 0.01 seconds. So that's the leading accuracy of the stopwatch. Okay. So that's that for time. I didn't miss anything. That's that for time. Now moving to the mass. It's very important for me to talk about the units of the mass. The unit of the mass is kilogram. Even though we have other units as well, but that's the one that is accepted in physics. For other units of mass, we have gram, we have pounds, we have gram, we have pounds, we have tons. We have quite a lot of them. And then you have a lot of instruments that are used to measure mass. Now, generally, all balances are used to measure mass except spring balance. Spring balance is usually used to measure weight of an object, not mass. Mass is different from weight. Weight is a force. Mass is just quantity of matter. It does not have direction. So spring balance is used to measure your weight, while all other balances are used to measure your mass. Example of all those other balances: you have your beam balance, you have your chemical balance, you have your lava balance, etc. And it's very important to note also, because you might be asked that on what principle do most of these balance works. Your your beam balance works using what? Principle of moment. While your chemical balance works using what? Law of electromagnetic induction. Take note of that. Your beam balance works using what? Principle of moment, while your chemical balance works using what? Principle of electromagnetic induction. And the measuring instrument that is basically used in the lab, in the physics lab, to measure mass is what? Your beam balance. And it has a reading accuracy of what? 0.01 gram. The accuracy of a beam balance is what? 0.01 gram. Now, that mention, I forgot to mention that the principle with which spring balance works. Now, we already said before that spring balance does not measure mass; it measures what? Weight. And the principle that it works, that it uses to work, is Hooke's law. And we already know Hooke's law now. Hooke's law said that what the force applied on an elastic object is proportional to what? The extensions, provided the elastic limit is what? Is not exceeded. We'll still go into that later on. Okay, so that's that for the mass as well. That's that for the mass. I didn't skip anything. That's that for the mass. So those are the major physical quantities that we usually deal with in the lab, that we usually measure in the lab. Now let's now go to fundamental quantities proper now. Now fundamental quantities, as I said, not fundamental quantities, physical quantities. Now it is not physical quantities that is divided into what? Fundamental quantities of basic quantities and derived quantities. Now what are fundamental quantities or basic quantities? Fundamental quantities are those quantities that are not dependent on any other quantities. That means they are standing alone. They are standing alone. They are not dependent on anything. Like it is them alone. And we have 7 of them. Even though later on you realize that we have 9. You have 7 of them according to your O-level textbooks. The first one is what? You have ml square. You have ml square, t square, ia. Yes. The m is what? Mass. The first L is what? Length. The second L is what? Luminous intensity. The T is time. The second T is temperature. The I is electric current, while the A is the what? Amount of substances. And each of those quantities have what? Units. For mass, it is kilogram. For length, it is meter. For luminous intensity, it is candela. CANDELA. For time, it is seconds. For temperature, it is Kelvin. For electric current, it is amperes. And then for amount of substance, it is what? It is moles. Now let's not talk about what derived quantities are. And the remaining 2 fundamental quantities that you might not be taught, that you might not even really see in any textbook, is you have your plane angle and your solid angle. The unit of your plane angle is radian, while the unit of your solid angle is steradian, STE. Then you have radian in front of it, STE, Okay, so those are your fundamental quantities. You are still going to come back to them later on. Then let's go to derived quantities. Now, derived quantities are all other quantities aside from your fundamental quantities. So once you know your fundamental quantities, that's all. You don't need to really start. Once you know your fundamental quantities, then you can just any other quantities that are not the fundamental quantities are all derived. I hope you get. So you don't need to stress yourself. And derived quantities are basically those quantities that are dependent on the fundamental quantities. So all other quantities are fundamental quantities. And there's a exercise I always tend to give, which I will give in another video for exercises where we treat about questions, is that I always tend students to like go through their physics textbook and write out formulas. Write out formulas of any quantities that they can find. It will actually help them in knowing more about derived quantities. Okay, now moving on, let's talk about dimension, which is the last part. Now, dimension is just you representing a particular quantity using a symbol of the fundamental quantities. Now, we always say that fundamental quantities they are standing alone, they are not dependent on anything. So that means all other quantities are depending on them. So basically, the dimension is just letting you know how how a particular quantity depends on the fundamental quantities. And what you always tend to do is you represent the fundamental quantities with a symbol. Like for mass now, it is m; for length, it is L; for time, it is T; for temperature, it is theta; for electric current, it's usually I or A. So now when you have all those, now let's say for example now you're asked to look for the dimension of velocity. Now velocity is equal to distance over time. Now distance is a form of length, so you have your L all over your time is what? T, L all over T. So that will give you what? L per T. Do you get? So that's basically how you actually go about dimensions. We are still going to solve more questions on that. And then it's a lot of dimensions. Now dimensions allow you to actually know whether a particular formula is right, because if the unit that you are getting on the other side of the you always tend to have equality sign between a particular quantity and the formula. So if the dimension that you have on the left side of the equality sign is not the same as the one that you have on the right side, then that means the formula is wrong. So then you obviously have to start to correct yourself and check where you made mistakes. So it allows you to actually know the test for the homogeneity of an equation, whether the equation is correct or not. Okay, so that's that for dimensions. In the next video, we are going to treat exercises on likely questions. We are going to see likely questions on this particular subject, and where in that video I'll be explaining it more better. So see you guys in the next class.